So example 1, it asks us to construct a circumcenter of triangle ABC, and circumcenter is probably a word you've never heard before. So let me highlight that and give you a definition. If you were to make a perpendicular bisector of any one of the three sides and then do a second perpendicular bisector of a different side and a third perpendicular bisector of the third side, those three bisectors will meet in one point, and that point is called the circumcenter. And basically the construction for a circumcenter is you're going to construct two perpendicular bisectors. You don't have to construct all three. If you did, they should intersect in the same point. So we need one perpendicular bisector. Let's say we did this perpendicular bisector and that perpendicular bisector. They're going to meet somewhere. Wherever they meet is where they meet. And that is the circumcenter. Okay, and the perpendicular bisector construction is what it was before. I'm going to take my compass. Maybe. Let's say I'm going to make the perpendicular bisector of AB. I'm going to take my compass, I'm going to put the compass point on A. I'm going to open my compass beyond halfway. Right? And then once it's beyond halfway, and again, you can ballpark where halfway is, I'm thinking somewhere in here, so I'm opening up beyond that. Once you make the decision, that's what radius is going to be, that's what's going to stay the whole time. I'm going to make an arc above and below. Like so. Okay, the radius I used there was random. It didn't matter what it was, but once I've made that decision, that's what my radius is going to be. I need to keep that radius the same all the way through. I'm going to take my compass, slide it over to point B, and I'm going to intersect the arcs. So I put a little arc here, and I put a little arc down here. My second arc I tend to have shorter because, I mean, the first one I'm not quite sure where it's going to be. The second one is pretty obvious where it's going to be. All right? Where those arcs intersect represent points on the perpendicular bisector. So then I take my straight edge, and I line it up on those 2 points. Like so. And then just draw a straight line through, like so, and that is the perpendicular bisector. Once you've constructed the perpendicular bisector of one side, now we go to the second side, either AC or BC, doesn't matter. I'm going to go to AC. I get to choose a new radius for this construction. I don't have to have the same one. If I want to use the same one and it's workable, it's fine, but I kind of like to stay within the arc there, so it's kind of big. Maybe I'm going to come back a little bit. Again, beyond halfway, that's the requirement. Doesn't matter exactly where, just go beyond halfway. And now AC, I want an arc on this side and this side of AC. So I'm going to take my compass and make an arc over here. And I'm going to slide it over here, put an arc over here. And then I'm I'm going to slide it over to see, and again, didn't matter what it was at that point, but now that I've chosen that, that's what it's got to stay. Can't change my radius at this point. So I'm going to put an arc here and here. Again, those arcs intersect at points on the perpendicular bisector. Once I've created those points, and I can just simply take my straight edge and I line up my ruler on those points. Being as precise as possible. Not very good. I'll try it again. And that's the perpendicular bisector of AC. Just to highlight this, and you don't have to mark this on your paper, but the perpendiculars happen here and here. These kind of almost look perpendicular to each other. They don't have to be, right? But that's where the perpendiculars happen. You're bisecting the side perpendicularly, so the perpendiculars, the right angles happen there. So the point of intersection of the two perpendicular bisectors is right here. That's my circumcenter, and I didn't specify what name to call it. Let's just call it D to give it a name. D is the answer. Now, the property of a circumcenter is it's the same distance from all the vertices. It just happens to be the same distance from all the vertices. So the verification of this proof, of this construction here, and I'd like you to do this on your homework and any problem involving a circumcenter, just to verify to me that you've checked your work, is you take your compass, you position the point on the circumcenter, open up to any one of the three vertices, doesn't matter which one. Again, my compass isn't perfect here. It jumps pretty big jump there. We'll go with that and just slide it a little bit. Get as close as possible as you can to one of the three vertices. Again, I'll just have to do what I can. And then if you take your pencil or your compass and make a circle, it should intersect the three vertices. Again, mine's off by a little bit because my compass just won't. I guess that's a little closer. There we go. I like the second circle better. Got rid of the wrong thing. There we go. If you did your circumcenter correctly, your circle should touch all three vertices. Because again, that's what the circumcenter is, the point equidistant from all three vertices. But again, the construction, any one perpendicular bisector, second perpendicular bisector, you don't have to do all three. If you did all three, they should all three intersect in the same spot.